Hello everyone, today we are going to talk about natural number exponent. So the topic is here, exponent laws. First, recall that we have already defined a number raised to a natural number power, that is a to the nth power equals to n times a times a times a, and here we have in total na. Now let's begin to introduce 5 exponent laws here. The first one is law 1, that is a to the mth power times a to the nth power equal to a to the product m plus n power. Now I will show you one example here. Let's see x to the 7th power times x to the 4th power. Here, let's compare the law 1 and this example. Since we have m equals to 7 and n equals to 4, then we can get the result by using the law 1 to x to the product 7 plus 4, that is x to the 11th power. Now let's move on to the second law. Law 2, that is a to the nth power parentheses to the mth power, which is equal to a to the product m times n power. Here is the following example, which is x to the 4th power parentheses to the 7th power, which is equal to x to the product 7 times 4, that is x to the 28th power. So let's move on to the third one, the law 3, which is a times b first, then parentheses to the mth power. In this case, we have to separate the a, b first, then we can get a to the mth power times b to the mth power. Now we are going to talk about the 2 different level examples here. First one is x times y parentheses to the 4th power, that is equal to x to the 4th power times y to the 4th power. Now let's move on to a little bit more difficult example here, like for example 2 times x squared times y cubed, now parentheses cube, then we can get the 2 cubed here times x to the product 2 times 3 power times y to the product 3 times 3 power. Here is the first, we can get 8 times x to the 6th power times y to the 9th power. So after the 3 exponent laws, we are going to introduce the laws for fraction. Now that is the law 4 here. First we have a over b, then parentheses to the mth power, that is equal to a to the mth power in the denominator over b to the mth power in the denominator. And similarly, we're gonna have two different level examples here. First is x over y parentheses to the fifth power, that is x to the fifth power over y to the fifth power. That's easy. And the second one is 2 times u squared over v cube, then parentheses cube, that is, let's solve the numerator part first. Like 2 cube first times u to the product 2 times 3 power. Then move on to the denominator part, which is equal to v to the product 3 times 3 power. That is 8 first times u to the product of 6 power. Then we can get v to the 9th power here. Now the last one is more difficult here, which has different results. The law 5 is a to the mth power over b. Oh, sorry. It should be a. Yeah. Still a here in the denominator. A to the nth power equals to, there are three different results here according to their different assumption. First one is if m is larger than n, then we can get a to the product m minus n its power. And what if m equals to m? Then the result is just one, single one, an integer. And the last one is if n is larger than m, then the result is 1 over a to the product n minus m power. So we are going to have the three corresponding examples here. The first is u to the 5th power over u. Since we have 5 larger than 1, so by using the first result we can have u to the product 5 minus 1, that is u to the 4th product. And the second example is d cubed over d cubed. In this case we have 3 equals to 3, so the result is just a single one. And the last one is y to the 4th power over y to the 6th power. Now we can see that 4 is smaller than 6, so we can use the last result of this last law, that is the 1 over y to the product 6 minus 4 power, that is 1 over y squared. So that's what we are going to cover these 5 exponent laws today. And now to make a condition that we can write it together. The first one is and the second one is now the third one is so when we talk about diffraction, that is also two relevant exponent laws here. The first one is this, and the last one is more difficult here, like this. with 3 different results. If a minus is larger than n, and the second is 1 if m equal to n, and the last one is 1 over a to the product n minus n if n is larger than n.